welcome to the next section, which is 2.3. So yesterday we started talking about parent functions and talking about their domain and range. And so the more of the time that we're spending on that, now we're going to learn more about the children of the parent functions. And so it's basically the same thing as the parent function, except they've been moved some way, transformed some way, flipped some way. So now we get to use some of those fun geometry words that we talked about in the past. So our learning target for the next few days will be to be able to recognize the transformations of parent functions. So again, being able to recognize what out of the 8 families that it's going to be a part of, and to kind of see what different operations are going on. And so this is leading us into a little bit of a Desmos kind of part. If you feel free to, if you want to play with some of these things on Desmos, I do have them typed in your note packet. So if you do type in the website the way it is, it will automatically take you to that website and you can play around with it and see what it is. So you can definitely do that. Also, it encourages you to just, incorporate by putting in different kind of functions. And so you can be creative with that as well. So the first one we're going to take a look at is we're going to take a look at what if I take a function and I multiply it by a value, any positive value. So we're going to have a positive value of a. And so we're going to kind of see what that happens. And so when we have that occurring, so the website will take you to right here. So I have that in there. And then you could just type in whatever parent function you want. So let's say I want a quadratic parent function. So then I'm going to have x, and then I'm going to have squared. So now I got to get my squared in there. All right, so there's my parent function. And some of you guys have seen me use this as Desmos before. And so if I have my a value, let's take a look at if my a is a positive number. So we're going to just look at positive numbers, not negative numbers. And so what I kind of want you to notice what happens with that. Okay? And so here I'm going to start adjusting it. And I want you to look at the red, not the black. So the black is the parent function. The red is going to be now what the a value is doing. So do you notice as that number is increasing, what we're going to be calling that? Okay, and so notice how it's, again, stretching, 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 and it's going, and it's going, and it's going. And so again, the a value is going to basically take that parent function. So here again is back at that parent function. And again, as I get more positive and more positive and more positive, then what's going to happen about the graph. So you can jot your notes down underneath that part, that first section. And so what did we notice about the graph? Again, it's just going to be, so this is something you could jot down under here. So again, you could mention something about the graph continuing where it's going to shoot up really fast as the a value is going more positive. And again, we're going to be, kind of, again, vertically getting that up, going higher. And we'll use a term for that shortly. All right. All right, now let's take a look at the second example. So what happens if I'm dealing with a negative in front of my function? That's like, in a way, having the a value become negative. And so that's what I'm kind of wanting you to think about. So what if I have a negative put in front of my parent function? What is it going to do? And so for our second picture, we're going to switch over and again go back to our buddy Desmos. And so here I typed in the link. And again, since we're kind of on a roll here, then let's continue using and studying with our quadratic. And again, you can play around with and pick other parent functions in which that you'd like to work with. So here's my parabola again. So again, my parent function. And so let's say now I'm going to take a look at right now if I have a negative function. And so what is that going to do? And so you just have to click on it. So notice there's nothing here. Now I click on it and there it is. And so now think about what kind of words did we talk about in geometry that we could talk about how did the black parabola now look like this new function of the green. And I'm hoping you're thinking of the word reflection. And so when there is a negative, again, that's going to give us what we call is the reflection of it. So when we replace f of x with that function and now have negative f of x, it is going to be a reflection of that particular parent function. And so that's what you're looking for that. And so that kind of leads you into the second graphic. So I'm wanting you to start noticing these relationships, because then when we take a look at an equation and a function, I want you to be able to say, oh, that's going to do this to it, this to it, this to it, and so forth. All right, back to where we were before. Here's our next one we're going to look at. And so now we're going to look at what if there's a number inside my function with my x. And some of you guys might have remembered me talking about this when we were talking about absolute value and when we were talking about parabolas. So we're going to go to that graph. Alrighty, I got that website typed in here and just switched back over to Desmos. And so again, I'm going to keep my same parent function. So I'm going to have x squared again. So there's my parent function. And so now we have that. And then here we're going to, again, have our y function. So this is going to change by some kind of h value. And notice we have a slider. And so what I'm wanting you to notice about is how is the graph changing as we change the y value. So I want you to consider if you change it positive or if you change it negative. So if we change it with a positive on my slider, notice it's moving to the right. It makes you kind of not want to think that because of this minus sign here. And remember, that's kind of when we talked about absolute value and how, again, it's kind of opposite of what you think it would be. It can't be trusted. The reason why is you are putting in a positive number, which is making it shift this way. So if there's a minus in my problem here with the h, if I put in a positive number, it's shifting my parent function to the right. And again, if I go negative, then that's going to turn that negative sign in front of the h to a positive, and that's showing me I'm actually going to shift it to the left. So again, if there's a number in with the h position, which I tried to show you a little bit and talk a little bit about this week, again, as a reminder, it's basically going to shift it left and right. And so because there's a minus in the formula, if we put in a positive number, it's going to shift the graph to the right. And if we put in a negative number, it's going to shift it to the left. Okay, moseying on. What if we take a value and we add something to our function? And so that's our k value. And again, I think you probably noticed some of these lovely things when we talked about that. So we're definitely going to be talking about that again. Okay, so we have that. I'm also missing the f equals bx, so I will go back to that one. For some reason, it is not on this screen, and I will grab that also for you. All right, here we are again, typing in that fun parent function. And again, I'm going with quadratic today. And so now let's take a look at what happens if we're adding a value outside of it. So we have a plus k value. Hopefully you remember this from when we studied absolute value and when we talked about parabolas in vertex form, that the k value can be trusted. What you see is what you get. So with my red one, let's again say I'm again changing it more positive. Notice that the k value is moving it up. And again, then it's going, if I go with a negative number, it's going down. So again, it's not changing, it's not moving left or right. Again, if I'm putting a positive number in there, it's going to shift it up. And if it's a negative number, it's going to shift it down. Now, the one that I didn't have on here that I really think we should talk about, which is in your notes, is talking about if we have f of bx. So what happens when there's a number in front of the x? And then what does that do? So here again is my function. And so I'm just going to be very steady and keep continuing with that quadratic. So what happens if there's a number in front of the x? Then what is it going to do? And so what we're going to do is we're going to click on this so we can actually see it. Right now b is 1, so that's not going to do much of anything. So let's say, what if it's a positive number? Notice again, it's making it skinnier. And we've taken a look at that. That's kind of what happened with my a value, if you remember before. And then that also affects other parent functions the same way. And then also, again, I can make it negative. And so I can do that as well. So notice if I'm multiplying it by a number, notice that the number is right in front of the function. Okay, so that means it's not outside it. So this is a little bit different. So if the number is in front of the function that's included with the x, then again, it's going to do something very similar to the a function. It's just that it's doing something very similar. Again, you could either narrow it up or make it fatter. And take a look at that. Okay. So far we've looked at almost all of these for this particular one. And so now what we have to do is I want to kind of put the sum of it together. We've got one more sketch that we're going to take a look at. So the one more sketch that we're going to take a look at is going to be this bottom one here. So if I put this all together, here's vertex format again of a parabola. Think about, and I want you to write down what you think A does, H does, and K does, because I tell you, if you can figure this stuff out, it's going to make your life so much easier, and you're not necessarily going to need to have to use a table. And it's also going to be really good too, because you can look at a function and look at an equation and say, okay, that picture does not match that graph. And so it's going to make your life a lot easier. So here's the last picture, putting it all together. Here again is our lovely, wonderful, again, vertex format. So if we want to put it all together with parent functions, your a value is basically going to do, again, an up and a down kind of situation. So that's when the number is outside. So like if it's quadratic, it's going to be outside the parentheses. So it's going to make it go, if it's negative, it's going to go down, or it's going up. Okay, so that's pretty much what your a value will do. That will do the same thing with your other parent functions. Very, very similar. H value is what we looked at separate. Remember? Oh, again, this is a minus here. So again, if I'm moving it with a positive number, it's actually going to the right. And again, because there's a minus in the formula, if this becomes negative, that's going to become a plus, which is going to move it to the left. And then my k value again moves it up or down. So again, you could have a parabola or a parent function that has 3 different things acting upon it. So you could have something where it is doing a vertical stretch. You could have something that's moving it to the right, and you could have something moving it up. And so therefore, it's kind of a combination of those kind of things. So to think about that with some of these things, with summarizing, you know, we're going to be talking about terms, and so I want you to kind of notice these things. And so when we talk together as a class next time, we're going to use that summarizing part of the page, and we're going to talk about, okay, is this a stretch or is this a compression? Is this vertical or is this horizontal? What is its factor? What does this do? Because then when we look at some of the pictures of the equations, we're going to be able to identify things and be able to talk about that particular equation. Okay, so this is the page we'll summarize together, but you'll have a worksheet that I want you to kind of try to figure out. And so what I would encourage you to do is come up with an example, maybe pick one of these and just graph it through Desmos and just see kind of what does it do, you know, and see if you can kind of figure out those terms. So this is going to be a little bit of a struggle day to try to kind of figure out what's kind of going on with these separate things. But I definitely think you guys are up for the challenge of being able to figure that out. Because my ultimate goal for you would be something like this, which we'll talk about on Friday. So if you look at this function, because remember it's a function because y is really f of x, this is again an absolute value function. That's the parent. Think about in your head, what does that minus do? Okay, and then what does the 6 do? Okay, and so I know what the equation of the parent graph is. The equation of the parent graph is going to be y equals the absolute value of x. Done. This picture does not represent this. So what I want you to think about is, okay, I'm not even going to try graphing it. What does this mean? What does this mean that I'm going to do? Well, hopefully you're going to be able to tell me, hey, Mrs. Cable, that minus means it's going to flip it upside down. It's going to be a reflection. And this 6 is going to tell me it's going to shift this graph up 6. And that's where we're headed. And so I'm going to want you to be able to, so try to take a look at your homework. I tried to go mostly with puzzles. So see if you can figure it out and try to figure out, look at the equation and see kind of what kind of operation, what kind of transformation is occurring on it. Okay? Bring questions for Friday, and again, guys, have a great day.